Today we are going to discuss about compaction and curing. So in the last lecture we discussed how the ingredients of specified quantities are to be batched and mixed in a RMC batching plant. Here the mixed concrete, when it is being placed in a formwork, how it should be placed and how it should be cured is to be seen in this lecture. How it is to be placed, compacted and cured will be discussed in this lecture. And this compaction is a process in which any entrapped air within the concrete during placing should be driven off to achieve full compaction. We know that when a concrete is being placed in a mold, it does not seldom conforms to the shape of the mold and it just forms a heap like structure, so that some air will be entrapped in the concrete. In this compaction process, our main aim is to expel those air voids so that our concrete takes the shape of the formwork. Just in compaction, we are trying to densify the concrete. That is, we are increasing the homogeneity . By doing so, we will be able to increase the durability property of the concrete also. So, our main aim of compaction is to drive the air voids, to densify the concrete and to increase the homogeneity. So, for doing so, we require some energy, and the required energy for compaction is achieved through oscillatory motion of the vibrate. The required energy for compaction is achieved through oscillatory motion of the vibration. Types of vibrators. To achieve compaction, we are using vibrators, and we have to supply energy to the vibrators through oscillation motion. And now we will be discussing about the types of vibrators which we are widely using to compact a concrete. Internal vibrators, form vibrators, vibrating table, surface vibrators. This internal vibrators can be of flexible shaft type or electric motor in hand type. So this internal vibrators will be having a flexible shaft either having a flexible shaft type or electric motor in hand type. And when the concrete is being placed in a mold, by using this internal vibrators, will be driving of the air voids by immersing it in the mold where the concrete is being placed. Here in this form vibrators are used where there is no possibility of doing any compaction. That is, it is a form of external vibrator. Here, when these form vibrators are used externally on the formwork, they'll transmit the impulse to the internal concrete. This form vibrators are mainly used where the reinforcement is provided in a congested manner. That is, there is no possibility of using internal vibrators. There we can go for this form vibrators. When these form vibrators are placed on the formwork, these vibrators will pass impulse through the formwork to the internally placed concrete. And these form vibrators will transmit the pulse both in the plane and the perpendicular to the plane. That is, if this is the formwork vibrator, then when it is being operated, it will be passing impulse on the plane and also perpendicular to the plane, so that the concrete in this portion will get compacted. These vibrating tables are largely used for precast works. These vibrating tables are mainly used for precasting works that are small in nature. The table itself will be vibrating, and when we place the mold on the table, based on the vibration due to the when we place the mold on the table, due to the vibration in the table, the concrete placed within the mold will also get the vibration and it will get compacted. Mainly used for precast works and to produce small RCC based works. And this surface vibrators will be placed on the surface of the concrete. These surface vibrators will be placed on the top surface of the concrete, and the impulse will be passing below, so that the concrete will get compacted. And these surface vibrators will be of vibrating screed, pan type vibrator, vibratory roller. The surface vibrators are mainly used for low slump concrete. So these are the types of vibrators which are being used to achieve compaction. And during this compaction process, actually two steps are involved, two stages, and during this compaction process two stages are involved. The first stage is the vertical settlement of coarse aggregate. First, when compaction is being done, in the first stage the coarse aggregate will get settled down. Since we have to fill the concrete to the shape of the formwork, we should able to liquefy the concrete. Liquefy in the sense the mobility should be given to the concrete. So in the first stage, the vertical settlement of coarse aggregate will take place, and in this stage air voids up to 5% will still remain, and in second stage the concrete will behave like a dense liquid, and the air voids will be removed easily. The reason for the concrete to behave like a dense liquid is because the given impulse, that is the waves, can move much faster in a liquid when compared to that of a solids. So in the second stage the concrete will behave like a dense liquid, so that any entrapped air within it can be removed easily, and also the mobility can be achieved. We are trying to liquefy the concrete so that the formwork can be, so that the concrete can fill the entire formwork. So our main aim is to drive the air voids out, that is we have to reduce the friction between the particles. So to reduce the friction between the particles, we have to liquefy the concrete, and that liquefaction process is being achieved in two stages. First stage, the vertical settlement of coarse aggregate takes place, and in that stage 2 we will be having around 5% of air voids remaining, and in the second stage it will behave like a dense liquid, and the remaining air will be entrapped when the dense liquid is being compacted. And next we are going to discuss about its execution process, how these vibrators should be used. Since our main aim is to remove the air voids, our execution process should be in such a manner that it should not disturb the formwork. Next we are going to discuss about execution process. By using vibrators, we are just applying impulse to the concrete so that it liquefies and attains the shape of the formwork. It doesn't mean that we have to move the concrete by using vibrators. We should not give any movement to the concrete where it is being placed. We have to just apply the vibrators, and we have to provide impulse so that the concrete moves within the formwork. Should not be moved using vibrators. If it is done, then it results in segregation, and the vibrators should penetrate to a standard depth, and the vibrators used should penetrate to a standard depth and should remain for some time, and then it should be taken out and should be kept at the other position. Should be should be embedded to a standard depth and held stationary and then removed. Regular spacing should be ensured. Overlapping is allowed. And this regular spacing should be ensured so that a complete compaction can be achieved. Suppose this is the impulse of the vibrator, then it will be transmitted in all these ways. Next, again I have to take my vibrator out and place it in the next position. If suppose I am placing it here, then the impulse will pass like that, so that this is overlap. This overlap ensures proper compaction. My particles can get rearranged accordingly when this overlapping is allowed, and minimum 10 seconds is allowed for proper compaction. And revibration is a special vibration where the vibrator itself penetrates into the concrete because of its self weight. There we can do this revibration, and this revibration can enhance, the performance of concrete in terms of its strength. So this reverberation is allowed when the concrete allows the vibrator to immerse inside without any external effect, and also this reverberation cannot be done in concrete when the vibrators are not allowed. This revibration is a special type of vibration given to the concrete to enhance the performance of concrete, and this reverberation is allowed when the concrete itself allows the vibrator to immerse inside under its own self weight, and also the penetration resistance when it is not more than 3.5 megapascal, we can go for this revibration so that our concrete characteristics can be improved. But when the penetration resistance is more than 3.5 MPa, we cannot go for this revibration. That is a special type of vibration for already placed concrete. Curing is a process in which the concrete is protected from moisture loss. So, and to prevent that moisture loss, curing is a process in which a concrete is protected from moisture loss. By doing so, we can achieve a concrete of desired strength and durability and decreased permeability. So this curing mainly we are doing to decrease the permeability and to increase the strength property, that is the moisture loss, the water cement ratio which is gone inside the concrete for the hydration process should be maintained as such, so that we will be able to achieve the concrete of the desired strength. We should take care such that the water cement ratio which was used during the concreting purposes should be the same, so that a concrete can achieve the desired property. Why it has to be done? Why we have to take care to maintain that water cement ratio? Since hydration reaction is not instantaneous, it takes long time. It's not an instantaneous reaction like exploring. Since this hydration reaction is not an instantaneous reaction, it takes some time, so we are going for this curing. Hydration reaction takes place at 100% relative humidity. This hydration reaction proceeds when there is 100% relative humidity. So in order to maintain that 100% relative humidity, we are going in for this curing process. And also our hydration reaction is not an instantaneous like bomb exploding. It's a time consuming process. So during that time consuming process, we have to ensure that we are providing this 100% relative humidity to get the desirable results. So mainly this curing is done to prevent loss of water by evaporation. Mainly this curing is done to prevent loss of water by evaporation process, and even if something happens, then it should be replenished. And internal water loss can also occur due to self-desiccation. So in order to prevent all this, we go in for curing. So since a hydration is a continuous process, and during that continuous process we have to see that the water which has initially gone in should not be lost by any evaporation process or self-desiccation process. We are providing 100 and either evaporation or self-desiccation, we are going in for this curing process. And also to maintain capillary segmentation, that is, there should not be any connected pores within the system. If this is a cement particle and this is a cement particle, then the hydration reaction proceeds from the outer surface, so some remaining inside unhydrated cement portion will be there. So if a proper curing system is allowed, then it ensures that all the products are being all the cement products are being hydrated. So capillary segmentation, if all the products are being hydrated, then these two pores will not able to touch each other. That is, there should not be any interconnected pores in the concrete system. So methods of curing. What are the methods we are following for this curing process? Moist curing, that is by ponding, spraying, etc. By doing so, by ponding for the roof slabs, just by creating some obstacles and storing water, we will be able to achieve the curing of concrete. And in spraying operation, we will be spraying the water to the vertical columns through means of a sprayer mechanism, and we will be maintaining the water and we will be maintaining the 100% relative humidity which is required for curing process. And next is membrane curing. In membrane curing, we will see that the water is not lost due to any evaporation process. That is, the amount of water which is went inside the concreting process will remain as it is when we go in for this membrane curing. But if there is any self desiccation, then that results in pore curing. Whereas in moist curing, we will take care of both loss due to evaporation and self desiccation process. That is, we will be replenishing the water by keeping the water stagnant over the portion where the concrete is to be cured. In membrane curing, only we will see whether the water is not getting by means of evaporation. And next is steam curing. In the steam curing, the concrete will be subjected to a higher temperature so that we will be able to achieve concrete of higher strength. But even doing so, the fresh concrete, when it is being subjected to a high temperature, will result in it is emphasized that a fresh concrete should not be subjected to high temperature. If it is being done, then it will spoil the concrete strength. That is, at the later stage, the strength of concrete will be decreasing. So the steam curing should be done. So the steam curing should be done in a stage where the end concrete is not subjected to a higher heat in the initial stage, and after the initial stage, then it can be, and after the initial stage it can be, and this steam curing can be done for concrete after the initial stage. That is, steam curing based on steam curing cycle. this is time in hours and this is temperature. 10, 20, 30, 40, 50, 60, 70, 80. This is the temperature and this is time. So at 20 degrees Celsius, suppose this is a fresh concrete, then we are allowing the concrete to be at the same temperature for some period, and then we are raising the temperature and again we are maintaining it for some period, and at the last stage we are cutting down the temperature. So this is the delay period, heating period, maximum temperature, and this is cooling period. The steam curing can be done for concrete based on this steam curing cycle. Based on studies, they have proven that when an end concrete is being subjected to a high temperature, will result in a low strength at the later stage. So in order to prevent that and also the other durability issues, the end concrete should be subjected to a low temperature for a minimum duration, and then it can be, and from after exposing it to a minimum temperature, the temperature to which it is being exposed can be raised, and after maintaining it for a certain period, we can again cut down the temperature, that is the cooling period. By doing so, we will be able to achieve the concrete of required strength within a shorter duration. That is the main purpose of this steam curing. Why we are going in for the steam curing is to get a concrete of strength attainment earlier within a shorter duration. That is, the steam curing is mainly used for pre-stressing. In pre-stressing of members, the steam curing mechanism for pre-stressing of members, in pre-stressing members, the steam curing mechanism is being followed so that soon the pre-stressing members can be cured and the members can be pre-stressed. So when there is a requirement of such that I have to get a concrete with of required grade within a shorter duration, I can go in for the steam curing, but that steam curing should be done as per this steam curing cycle, so that we will get a concrete of required property. And that's all about compaction and curing.